Synthetic division is a tool that's going to be quite useful to us when we're finding zeros of polynomials. So here's the process for doing synthetic division. Step 1. We're going to take the coefficients of the top polynomial, write them horizontally in descending order of the exponents, meaning just in the order they appear. So this would be 4, negative 15, 11, and negative 10. Step 2. The bottom has to be an x with a plus or minus some number. If it's not, synthetic division doesn't work. However, out in front of these numbers, we put the opposite of this. If this is a negative 3, we use positive 3. The rest of the process, as far as what to do, is pretty straightforward. It's very automated. You add vertically. For example, 4 plus nothing is 4. And then you multiply horizontally. 3 times 4. And write that above the line under the next number. And then repeat the process. Negative 15 plus 12 is negative 3. 3 times negative 3 is negative 9. 11 plus negative 9 is 2. 3 times 2 is 6. Negative 10 plus 6 is negative 4. You'll get the hang of it before too long. However, that's the process. What does it give, though? The 4 on the front is actually the coefficient on an x. In particular, since this was x to the 3, this is x to the 2. And then the 3 is an x, the 2 is a constant, and the negative 4 is the remainder. Typically, we write the remainder as a fraction. Let's try that on a separate problem. Step 1. The number out in front, step 2, for this one, would be negative 2. We draw the line, add, starting here. Multiply, add, multiply, add, multiply, and add. This was x to the 3, so this 5 means 5x to the 2. Now, just being able to divide these things might impress some folks, but that is not why we're learning it. Now, this one has a little unusual quirk that you need to be careful to pay attention to. If you look at this polynomial, you see here an x to the 4, then an x to the 3, then an x to the 1. How about the x to the 2? There's not one. So when we do synthetic division, we're going to have to make provisions for the x to the 2 not being there, as in this. Here's the negative 3 on the x to the 4. Here's the 15 on the x to the 3. There's no x to the 2, so we need a 0 there for x squared. Then the negative 50 and the 25. So this is talking about finding f parentheses 4. What that means is we're going to do synthetic division with the 4. When we're finished, the number that appears in this spot is f of 4. We still have to go through the process though. So step 1, our first thing to do is add. Negative 3 plus nothing is negative 3. Multiply. 4 times negative 3 is negative 12. Add. Multiply. Add. Multiply. Add. Multiply. And add. So there's our answer. Now I will give you a little heads up. Doing synthetic division just to evaluate a function is not a very good use of synthetic division. If I needed to evaluate this function for x equals 4, I would type that into my calculator. So you can probably guess that on this one we are going to do synthetic division. So let's see. Here we have the 2 for the 2x cubed minus 3x squared. Notice anything missing? 0 for the x, and then the negative 18. We're going to use a 2 in our synthetic division. When we do our process, we add, multiply, add, multiply, add, multiply, and add. Now, if you've been listening for the last few times I've been doing this, the number that we come out with here is the remainder, which means if this were a 0 of the polynomial, the remainder would be 0. There would be no remainder. That's what 0 of a polynomial means. So the answer here is no, it is not a 0. Now I would venture to say that you've never experienced a 4th degree polynomial before. However, there is no difference in the steps. We're going to take the negative 3 and do our process. Add, multiply. Add, multiply. Add, multiply. Add, and multiply. And add. Now this is what I said in the previous problem. Since this number is a 0, our answer is yes.